Imagine a world where information travels at the speed of light. This is the promise of optical fiber. It is the backbone of our modern digital age. Optical fiber is like a thin thread of glass. It transmits information as light pulses. This technology has revolutionized the way we communicate. Optical fibers are incredibly thin. They are about the width of a human hair. Don't let their size fool you. These fibers are powerful carriers of information. They transmit data over long distances with minimal loss. This is a huge leap from traditional copper wires. Before optical fiber, copper cables were the norm. Copper cables are limited in speed and distance. They are also prone to signal loss. Optical fiber solves these problems. It offers faster speeds, greater bandwidth, and longer transmission distances. The internet as we know it wouldn't exist without optical fiber. Neither would high-definition video streaming or online gaming. This technology has transformed how we connect and access information. It continues to shape the future of communication. Optical fiber harnesses the power of light. Light travels incredibly fast. It is the fastest thing in the universe. But how does light travel through a thin glass fiber? The answer lies in total internal reflection. Imagine shining a flashlight into water at an angle. The light bends, called refraction. Increase the angle, and at a critical point, light reflects back. This is total internal reflection. Optical fibers use this to guide light. The core is where the light travels. The cladding has a lower refractive index. This traps the light within the core. Light pulses travel through the fiber, bouncing off the cladding walls. These pulses represent data, like emails, videos, and phone calls. The light pulses travel incredibly fast. They reach their destination with minimal signal loss. Optical fiber is a game changer for data transmission. It has two key advantages: high capacity and high speed. These advantages stem from the unique properties of light. Capacity refers to the amount of data that can be transmitted at once. Optical fiber has a much higher capacity than copper wire. This is because light waves oscillate at a much higher frequency than electrical signals. Higher frequency means more data can be encoded onto the light wave. Think of it like a highway. A copper wire is like a single-lane road. An optical fiber is like a multi-lane highway. More lanes mean more cars can travel at the same time. Similarly, the higher frequency of light allows for more data to travel simultaneously. Speed is another major advantage. Light travels much faster than electricity. This means data transmitted through optical fiber arrives at its destination much quicker. This is crucial for applications where latency is critical, such as online gaming or financial trading. Section 4. Immunity to interference. Optical fibers offer another crucial advantage: resistance to electromagnetic interference. This immunity stems from the nature of light itself. Electromagnetic interference, or EMI, is a common problem in data transmission. It occurs when external electromagnetic fields disrupt the signal. Copper wires are highly susceptible to EMI. This can cause data corruption and signal loss. Optical fibers, however, are immune to EMI. This is because light is an electromagnetic wave, but it doesn't interact with external electromagnetic fields in the same way that electrical signals do. The light signals within the fiber remain unaffected by interference. This immunity is critical in many environments. For example, in industrial settings, heavy machinery can generate significant EMI. Optical fiber ensures reliable data transmission even in these challenging conditions. This makes it ideal for applications requiring high data integrity and security. Section 5. The challenges of light. Despite its many advantages, optical fiber technology also faces challenges. Two key challenges are cost and fragility. Addressing these challenges is crucial for wider adoption and implementation. Optical fiber is generally more expensive to install than copper wire. This is because it requires specialized equipment and expertise. The glass fibers themselves are also more delicate than copper wires. They require careful handling during installation to avoid damage. Once installed, however, optical fiber can be more cost-effective in the long run. Its higher bandwidth and lower maintenance costs can offset the initial investment. Fragility is another concern. Optical fibers are susceptible to damage from bending, crushing, or stretching. A break in the fiber can disrupt the entire transmission. This requires careful installation and protection. Section 6. A bright future: applications and advancements. Optical fiber is indispensable in many fields. Its applications expand as technology advances. Key areas include telecommunications, medicine, aerospace, and defense. It forms the backbone of the internet, enabling high-speed data transmission, used in endoscopes for minimally invasive surgery, providing lighting and visibility inside the body. In aerospace, they reduce weight and improve reliability, crucial for secure military communication, resistant to interference, ideal for sensitive data. Advancements push boundaries further. New fibers with higher capacity and speed, space division multiplexing or SDM is promising, transmitting multiple data streams through a single fiber. The future of optical fiber is bright. Expect faster speeds, higher bandwidths, and new applications.